Hi everyone, this video is an exercise 13F, the challenge question, and this is the second question of the challenge. So in this video, we have this curve, and this is a very interesting question, by the way. So we have this curve, and the equation is equal to x times x minus 1 times x plus 2. And this crosses the x-axis at the origin on point B. So this is point B, and also this point. So now the shaded area, which is the blue region, above and below the x-axis are equal. So that basically means the area of this region here on the left is equal to this region on the right. So that's very important. So in part A, we want to show that the x coordinate of A satisfies this equation. Okay, so the question may seem confusing at first, but let's just start with what we are given, and that is this fact. So the shaded areas above and below the x-axis are equal. So the shaded area of this left region is simply equal to the integral of, so the integration is between a, so we don't know a is the lower limit, and then 0, and obviously the function itself, which is x times x minus 1 times x plus 2 dx, and it is equal to, as the question says, to the area of the other region, which is, this one is between 0 and the coordinate of b. But we know that because if you look at the roots of the equation here, so one of the roots is equal to 1. Obviously one of them is equal to 0, and the last one is equal to minus 2. So minus 2 is here, and then b has x coordinate 1. So this is the integral for b, but the function itself is the same. But there is only one thing that we should be careful when we are setting up the equation, because the region here between 0 and b is under the x-axis. So remember, the output of the integration is going to be negative. But since the question is about area, we want area to be positive, because negative area doesn't make sense. So we just put a negative sign before the integral, just to basically to cancel that negative output at the end, so we get a positive area. It's just something that we should be careful. Okay, now that we have this equation, then we can move this integral to the left hand side and then simplify that. So you'll see that yeah, let's write that first. So we have x times x minus 1 times x plus 2 dx. Then this one becomes plus, again, the function itself is the same, just the limits are different. So as you can see, since the integrand, which is what we have inside, the two integrands are the same, we can basically combine them and make this one single integral. The only thing is just about the limits. So remember, the highest limit is 1 and the lowest limit is a, because the limits are, as you can see, connected. So it's essentially between a to b. So we can just simply write the limits as a to b. Obviously b is equal to 1, and then the integrand is just x times x minus 1 times x plus 2 dx. Okay, as you can see, we have a simple integral now. We need to expand this bracket first and then integrate. So we have, let's quickly expand that here actually. X times x squared plus x minus 2, which is equal to x cubed plus x squared minus 2x. Okay, so now that we have this, we can simply write the integral of x cubed plus x squared minus 2x dx, and this is equal to a fourth of x to the power of 4 plus a third of x cubed minus x squared, and that's between 1 and a. So for the next part, we just substitute 1 and a. Also, I forgot to write this down, because once we made the two integrals just the same, remember that we had an equation at the first place, right? So it was the left integral is equal to the right one. So when we move the integral from the right hand side to the left hand side, obviously on the right hand side we'll have just 0. So I forgot to write that here. So yeah, the reason is equal to 0 is because when we move this from the right to left, nothing, remains on the right hand side of the equation. So that's why we will have 0. So that means this integral itself, once we find the values, it is equal to 0 because of that. So at this point, we just now need to substitute 1 and a, and then the entire thing is going to be equal to 0. So when we substitute 1, we get 1 over 4 plus 1 over 3 minus 1, and then minus a substituted, which is 1 over 4 a to the power of 4, 1 over 3 a cubed minus a squared. And this is equal to 0. Okay, so now we can simplify this bracket. So this is simply equal to minus 5 over 12. And after that, we have minus a to the 4 over 4 plus a cubed over 3 minus a squared is equal to 0. So now we can multiply both sides by 12 to get rid of the denominator. So we have minus 5 minus 3a to the power of 4 plus 4a cubed minus 12a squared is equal to 0. And now we can multiply by 1 to just have a nice equation. So we are going to get 3a to the power of 4 minus 4a cubed plus 12a squared plus 5 is equal to 0. Okay, so this is the interesting part, because remember, now we have this equation. So far we have been just solving the integral, and then this is what we'll get at the end. And in fact, the solution to this equation, one of the solutions is going to give us the x coordinate of a, right? As you can see, solving this equation is literally going to give us a. So it's just now about solving this equation, and obviously in order to solve this, we need to use the factor theorem. So we just need to guess one of the roots and then use the long division. So because of that, obviously 0 is not going to work. But when we try 1, when let's say a is equal to 1, we have 3 minus 4 plus 12 plus 5. And before that, I just noticed one mistake here. So here we have minus 4a cubed, and yeah, because here is a negative, so I forgot to take that into consideration. So this term also becomes positive. So positive 12a, and once we multiply by minus 1, we have positive 4a cubed but negative 12a squared. Okay, yeah, again, when we try 0, it doesn't work, but when we try 1, we'll have 3 plus 4 minus 12 plus 5, which is equal to 0. So from factor theorem, we can realize that one of the, basically a minus 1 is a factor from a factor theorem. So because of that, we can simply now just use long division and get this 4. So we can already see that 1 is actually a repeated root. So yeah, but we can use the long division to achieve that. Okay, so we can write 3a plus 4a cubed minus 12a squared plus 5 divided by a minus 1. So we can have 3a cubed here, which is 3a to the power of 4 minus 3a cubed. So subtraction is going to give us 7a cubed minus 12a squared plus 5. And then we have 7a squared here, so we get 7a cubed minus 7a squared, but subtract again, so we get minus 5a squared plus 5. And finally, minus 5a here, minus 5a squared. Yeah, so basically we get positive 5a. So we subtract and we have minus 5a plus 5. And finally it's minus 5. So minus 5a plus 5, which is 0. Okay, so basically what we got as a factor, so the entire equation is 3a to the power of 4 plus 4a cubed minus 12a squared plus 5. But we found that a minus 1 is a factor, and also with long division we have 3a cubed plus 7a squared minus 5a minus 5 is another factor. And interestingly, so here what's happening is that we have a cubic now, so we just need to go through this process again. So for another long division with another basically factor theorem. But it's interesting because for also 3a cubed plus 7a squared minus 5a minus 5 is equal to 0. Again, a is equal to 1 is going to give us 3 plus 7 minus 5 minus 5, which is equal to 0. And this is in fact another root. So a minus 1 is also is a factor, again, from a factor theorem. So therefore that means that we can then go through the long division and just divide this cubic by a minus 1. And as a result of that, we are going to get this. So this time I'm not going to solve this to save a bit of time. I mean, to solve the long division, I will just write down the factors. So a minus 1 is obviously a factor. But the next term, which is a quadratic, is that 3x squared plus 10x plus 5. And that's indeed what we wanted to show. So, yeah. Or actually, yeah, let me maybe go through the division just in case there is any confusion. So, yeah, let me just derive this quadratic here. So 3x squared plus 10x plus 5. So we have 3a squared here, so we get 3a cubed minus 3a squared. So we take away and we get 10a squared minus 5a minus 5. So we have 10a here, which is 10a squared minus 10a. So subtract again and we get 5a minus 5. So we just simply do 5 here. So that gives us 5a minus 5, which is 0. Yeah, and that's indeed the quadratic, so 3a squared plus 3a plus 5. Right, so therefore we have fully factorized, and we can then say that, okay, 3 a to the power of 4 plus 4a cubed minus 12a squared plus 5 is equal to a minus 1 squared, because remember we have two factors of a minus 1, so that's just a repeated root, and then 3a squared plus 10a plus 5. That's exactly what we wanted to show. So here I think they have used x, so we can then at the end just replace that with x, but I don't really like the idea that they have used x here, because when we do the integration we substitute a. But anyway, yeah, so this is part A. I'll do the next part in the next video.